Hello everyone, this is Dr. Fan. Very recently, one of my students asked me this very interesting college board question. And I think this question is very good, so I want to share it with you. The student thinks this college board question is wrong, and he wants me to explain it to him. If you are able to understand this question in great depth, you should be able to solve the majority of the questions related to work and energy. Because of that, let's discuss it today. So block 1 has a mass of m, and at the bottom of the ramp it has a velocity of v. It climbs a height of h and reaches the top of the ramp. And there is another block, block 2, which has a mass of 2m, and at the bottom of the ramp it has a velocity of half v. It also climbs a height of h and reaches the top of the ramp. And the question asks the gravitational potential energy change for block 1 and the gravitational potential energy change for block 2. The student choose option A. He thinks the gravitational potential energy change for block 1 divided by 2 equals to the gravitational potential energy change for block 2. And this is his reasoning. He uses the conservation of mechanical energy. So mechanical energy has two parts, kinetic energy and potential energy. And this is his procedures. For block 1, he thinks the initial mechanical energy has two parts. The first part is kinetic energy, half mv squared. And he considered the bottom has a reference height of h, so the gravitational potential energy is 0. And at the top, he thinks the kinetic energy is 0, so 0 kinetic energy plus the gravitational potential energy for block 1. So he got UG1 equals to half mv squared. And for block 2, he did the same thing. For block 2, the initial mechanical energy equals to half times 2m times half v squared, because the block has a mass of 2m and a velocity of v divided by 2. And the initial potential energy is also 0. So the final mechanical energy equals to, at the top, he thinks the kinetic energy is 0, so 0 plus Ug2, the gravitational potential energy for block 2. Then he got Ug2 equals to 1 over 4 mv squared. And because of this relationship, he thinks Ug1 divided by 2 equals to Ug2. That's why he chose option A. But the answer turns out to be C. So he wondered if this question is wrong or not. After reviewing his procedures, I asked him one question. How does he know the velocity of the block on top of the ramp? Maybe there's a residual velocity for both blocks. Then he read this question again and realized this question did not mention the velocity of the block on the top of the ramp. So he asked me, then how should he solve this question? I asked him, what's the definition of gravitational potential energy? He told me it is mgh. Because the mass would not change, so the change of gravitational potential energy basically equals to the change of height. So it's mg delta h. And for block 1, the delta Ug1, very straightforward. Mass times g times the change of height, which is h. So for delta Ug2, for block 2, it equals to 2m times g. The change of height is h. So you got 2mgh. And based on these two values, you can see that 2 times delta Ug1 equals to delta Ug2. So the correct answer should be C. But this question is not done yet. In order for him to better understand the concept, I asked him a follow-up question. So if we say for block 1, its velocity at the top is v1, and for block 2, its velocity at the top is v2. I asked him, what's the relationship between v1 and v2? After some calculation, he told me he thinks v1 is larger than v2, and these are his calculations. So for block 1, he did this. Now he realized this block at the top may still have velocity, so he uses the conservation of mechanical energy again. So the initial mechanical energy equals to half mv squared plus 0 potential energy, and the final mechanical energy equals to half mv1 squared, because it may has a residual velocity, and then plus its gravitational potential energy, which is mgh. So after calculation, he found out v1 squared equals to v squared minus 2gh. For block 2, he did the same calculation. So the initial mechanical energy for block 2 is half 2m times half v squared plus 0 gravitational potential energy. And the final mechanical energy equals to half 2m v2 squared, because the mass is 2m, plus 2m gh. After calculation, he found out v2 squared equals to v squared divided by 4 minus 2gh. By comparing these two equations, it's clear v1 is larger than v2. But I asked him a question. If you want to use the conservation of mechanical energy, you gotta make sure there is no friction. But in this question, whether there is friction or not, we don't know. So you cannot just use conservation of mechanical energy without considering if there is friction or not. This student is very smart. After calculation and considering the work done by friction, he still insists v1 is larger than v2, and these are his procedures. So now he uses this equation. The net work done by friction equals to the change of energy. In other words, the work done by friction equals to the final mechanical energy minus the initial mechanical energy. And his procedures actually are very nice. So the work done by friction equals to the final mechanical energy for block 1, which is half mv1 squared plus mgh. This is the final mechanical energy. The initial mechanical energy is half mv squared. From this equation, he gets v1 squared equals to 2 times the work done by friction divided by mass plus v squared minus 2gh. And he did the same thing for block 2. So the work done by friction for block 2 equals to the change of energy for block 2. And this is the final mechanical energy minus the initial mechanical energy. And this equation can also be written as half 2m v2 squared plus 2m gh. This is the final mechanical energy minus the initial mechanical energy, which is half 2m times half v squared. And from this equation, he got v2 squared equals to the work done by friction to block 2 divided by mass plus v squared divided by 4 minus 2gh. So this term and this term here is the same as this term here. The only difference is the work done by friction here. And the student is very smart. He thinks this term here and this term here are the same. And this is his reasoning. So because two ramps are the same, so at any position, let's imagine the block is here. This block is under gravity is also under normal force, which is also under friction here. So the block is moving up, and the friction is parallel to the ramp, but going to the opposite direction. So friction will do work. But more importantly, he thinks, if we know this angle here, because along the y direction, the block is now moving. That means the normal force equals to Fg times cosine theta. And the kinetic friction force equals to mu k Fn, which is mu k times Fg times cosine theta. So he actually found out the friction force at any position on the ramp. For block 2 at the same position, the free body diagram is the same. We got gravity here, we got normal force here, we also got friction force here. Let's call it friction force 2. And you would get the same equation. The friction force here equals to mu k Fg2 times cosine theta. Because block 2 has a mass of 2m and block 1 has a mass of m, so the friction force on block 2 is actually 2 times the friction force on block 1. And also because the distance is the same for both blocks, then the work done by friction on block 2 is 2 times the work done by friction on block 1. As a result, if you compare this term here and this term here, these two terms are the same. Because of that, he thinks V1 is still larger than V2. I really like his calculation and how he derived this friction force. There's only one problem. The question didn't mention the friction coefficient between the block and the ramp. So we don't know if they have the same friction coefficient between the blocks and the ramp. Besides that, all his calculations are correct. The student told me he agrees with what I said, and now he has a much better understanding about work and energy. Okay, there are several takeaways for this question. The first takeaway is, when solving physics questions, you want to extract the correct information. In this question, the student first assumes the velocity of the block at the top of the ramp is 0, which is not true. When he uses the conservation of mechanical energy, he assumes there is no friction, which we don't know. And also he assumes they have the same friction coefficient, which we don't know. So in order to extract useful information from the question, you want to use the information given by the question. You cannot just assume some information that doesn't exist in the question. That's the first takeaway. The second takeaway is, when finding a certain quantity, always try go back to the definition, because that gives you the most accurate result. In order to find the gravitational potential energy, its definition is mgh. If you try to find the kinetic energy, its definition is half mv squared. If you want to use some other laws, make sure the conditions are being satisfied. For example, if you want to use work-energy theorem, so the work done to the system equals to the change of kinetic energy, you gotta make sure the condition is it's either a point mass or it is a rigid body without rotation. Otherwise, you cannot use this equation. If you want to use the conservation of mechanical energy, you gotta make sure there is no non-conservative force. Otherwise, you cannot use this equation. Instead, you should use the work done to the system equals to the change of the energy for the system. I hope our discussion today helped you to better understand the concept, but also help you to better solve the physics questions. Thank you. I will see you next time.